My name is Andee Rubin. I work at TERC in Cambridge, Massachusetts, and today I will be talking about data as an authentic gateway into mathematics. I will start by telling you why data is so important, at least to me. I will give you a very brief history of data in the math curriculum. I'll spend a lot of time talking about what I think are the most important central concepts in data. And finally, I will illustrate those with examples from a project that we did introducing middle school students to data science. So I've been interested in data science for over 40 years. And this quote is actually from quite a while ago, but it holds as true today as it ever did. This is from a curriculum developed in the 1980s at TERC that introduced elementary school students to ideas about data. And the introduction to it, I think, is important for all of us, and I will read it. We introduce students to good literature in their early years. We do not reserve great literature until they are older. On the contrary, we encourage them to read it, or we read it to them. Similarly, we can give young students experience with real mathematical processes rather than saving the good mathematics for later. Through collecting and analyzing real data, students encounter the uncertainty and intrigue of real mathematics. So I think of interacting with data as real mathematics, and I think it's important to pay attention to those words uncertainty and intrigue, which we don't always associate with mathematics, but are part of data analysis. I also think that data is math that matters, and I wrote an article 15 years ago talking about how important it is to include data literacy in the high school curriculum, which is a topic that is very much top of mind these days. And I think data belongs not only in mathematics, but in other subject areas as well. Here's a very, very brief history of data in the math curriculum, just to give some context to where we are now. In 1989, the National Council of Teachers of Mathematics standards came out, and statistics and probability were standards K-12. And the curricula around statistics and probability were developed at all levels. That's where the use numbers curriculum came from that era of math education. In the Common Core, measurement and data is a content area, but much of the focus is on connections between data representations and arithmetic operations. So things have changed a bit since 1989. In the last 5 years, data science has really arisen on the national and international stage and is now seen as critical content across the curriculum. So we're in kind of a new era where people recognize the importance of data. And I like to go back to 1989 to remind us all that we've thought about data before, and there's a lot of wisdom in the work that has come before that we need to go back to as we're excited about data science. So some people think data science is a new topic, but I believe that the ideas that have been part of data and statistics for many years are just as important now in the data science era as they've ever been. And so I want to organize this central part of this talk around what I think are these 5 big data concepts. And these are described in more detail in a paper that I wrote in 2020 in the Journal of the Learning Sciences. And these 5 ideas are context, variability, aggregate, visualization, and inference. And I will go through each of these and give you some ideas of what I mean by them before I show you how they were instantiated in a middle school curriculum. So the first is context. And for this, I want to go back to some of the most venerable statistics educators of our times, George Cobb and David Moore, who in 1977 wrote the following: "There is more than just content that distinguishes statistical thinking from mathematics. Statistics requires a different kind of thinking because data are not just numbers, they are numbers with a context." So anytime we work with data, data are measurements that were made of some objects in the real world, but that act of measurement is complicated, and often we capture some things about the real world and don't capture others. And so we always want to know, how were the data measured? Who did the measurements? Why did they measure them? When, where, and who did we include and who was not included? So these days, especially when we're working with data that other people have collected, those are really important questions to ask. I'm going to use for this example an old data set, which is not of great import, but which I think is dear to my heart because I was involved in its collection. And this is a data set of 24 domestic house cats. And my cat is one of these. These cats, unfortunately, are no longer alive because this data is from 1990. But just to take a look, we have the name, the sex, the age, the weight, the body length, the tail length, eye color, pad color, and fur color of each of these cats. And if you really think about it, the first question you might want to ask is, how did we get the cats to stand still so that we could measure their tail length? And when we measured their body length, did we make sure the tail was out of the way? So these are all questions that you would ask about any data set, and they're just as relevant with this data. So this is the context of these cats, and we have to remember to ask all of those who, what, when, where, and how questions about any data set that we look at. So I'm going to take a slight detour and talk about visualization. So these days, we are not limited, and students are not limited to graphs that they can draw by hand because we have wonderful tools. And the tools that I'll be showing you the tool that I'll be showing you is CODAP, which stands for the Common Online Data Analysis Platform. And this is an example of a visualization from CODAP, and you can see that it has thousands of data points. And these data points are showing the rate of central line infections in hospitals all over the country. You can see that the hospitals in California are in blue. The rest of the hospitals are in orange. And similarly, the measurement from hospitals in California are in blue in that graph on the left. It was really easy for students to make this visualization. And so instead of spending their time really plotting point by point, students these days can spend their time interpreting these kinds of visualizations, asking questions like, are the hospitals in California similar to the rest of the hospitals in the country? Where are those hospitals where the infection rates are really high? How can we find patterns in the data that we might not see if we were just looking at a table? So the point of visualization is to allow us to tell stories with data and to see the patterns in data that would not be visible otherwise. We're lucky that we have computer tools now that are powerful and that are accessible to students K-12. So the next of the important data concepts that cut across all of statistics and data science is the idea of variability. We can go back to Cobb and Moore, and what they said was the need for this discipline of statistics rises from the omnipresence of variability. So what does that mean? It means that if we take any measurement in the world, and let's say with these cats, we measured their weight, they're going to be different. They'll vary across individuals. And even repeated measurements on the same individual can vary. So how do we draw conclusions given this kind of variability? In algebra, we don't have the same kind of variability. In arithmetic, we think there's an answer to a question. But here, if we ask the question, what weight is the cat? We have 24 different answers. And so statistics really was developed as a way to deal with this kind of variability and still make it possible for us to make some statements that we can base actions on, base conclusions on. So here's variability. How would we answer a question like, how much do cats weigh? And statistics gives us some ways to answer those kinds of questions. And the way we describe those kinds of techniques are aggregate techniques. So if we look at this graph, which I've now divided all the cats into male and female. So I have all the male cats' weights on the top and all the females' cats' weights on the bottom. How do we make a statement about the comparison between male and female cats in terms of weight? So a lot of what people do when they look at graphs like this is they want to look at each individual point, and that's fine and easy to do. Each of those points is a singular cat. And students in particular tend to do that kind of case-based reasoning quite easily and sometimes get stuck doing that. But we want to be able to say here's something about male cats in general and female cats in general. And I've put on here the median for the male cats and the median for the female cats. Those are aggregate measures. They're measures that say something about the whole group. So we see that the median weight for the males is about 11, and the median weight for the females is about 9 pounds. So that tells us something in general about cats. It doesn't tell us about every single cat, because we notice that there's one really heavy male cat and there are a couple of heavy female cats. But statistics is about being able to say something about data that show variability. And this is the way that we approach being able to compare two distributions. So students need a lot of support in being able to use these aggregate measures and knowing what their strengths are and what their limitations are. And this gets us to the last concept, which is inference. So inference in statistics is something that people think of sampling and p-values, and it's generally regarded as a very advanced topic. But it's important even for young students to ask the question, what about what we've learned might apply to other data? So in this case, we have 24 cats and we see a pattern. We see that the male cats are generally heavier than the female cats. But what if we looked at another 24 cats, or what if we looked at 100 cats? How sure are we that the conclusions we've drawn from this data would apply somewhere else? So if students are collecting data in their classroom and see a pattern, the question would be, what if we go down the hall and we ask students from another classroom? Will we still see the same pattern? And a group of international colleagues and I have come up with an idea called informal statistical inference. And it's a way of thinking about what young students should be considering when they find patterns in data and then want to think about how generalizable they are. So that's a big piece of statistics, is thinking, what did I learn from the data I looked at? And then how sure can I be that I can take that data and apply it, take that conclusion and apply it to another set of data? So inference is important not just at the higher levels of statistical reasoning, but for young students as well. And we like to think about informal approaches to inference. So let me now talk about a project that I was involved in that tried to introduce middle school students to all of these important ideas about data. This was the Data Clubs project. It was a collaborative project between TERC, where I work, and Science Education Solutions. It was funded by NSF. And we developed some after-school and summer camp materials, 3 different modules, each of which took about 10 to 12 hours of contact time. And our participants were 12 to 13 years old, entering the 7th or 8th grade. And each of our modules was not focused on a statistics topic, but it was focused on a real world topic. And we used large publicly available data sets, because that is what we have available these days that we didn't have available 20 or 30 years ago. And the 3 topics, the first one was teens and technology and time, how teens use both technology and their time, Lyme disease and other tick-borne diseases, and injuries on and off the field, where we looked at injuries that youth sustained that took them to an emergency room. And as I mentioned previously, the primary tool that we used was CODAP, the Common Online Data Analysis Platform. You've seen a couple of examples of what CODAP looks like. And I just want to say that it is a free web-based analysis tool that I recommend to people in schools. Take a look at it. It's very accessible. So I want to tell you a story about a group of students who used the Teens, Tech, and Time module. And the hook for this module was the lead article in the Boston newspaper at the time we were implementing the module. So that was 2018. And the headline was that 45% of teens say that they are online almost constantly, according to a new Pew Research Center study on teens and social media use. So we took that data set and we took that statement and we used that as a way to engage our group of students. So the data set that we used was, pay attention to the date here, the Pew Research Center Technology and Internet Use 2014 survey. And keep in mind that date. And the data set was derived from a very long 37-page interview that had been administered online to parent-child pairs. It had about 1,200 cases and over 300 variables. So we couldn't really use that much data with the group that we were with. So we curated a data set with 10 variables and 200 cases, and we gave it to the students and asked them to start analyzing it. So the first question that they looked at was the following: which of the following social media do you use most often? And look at this list: Facebook, Twitter, Instagram, Google+, Snapchat, Vine, and Tumblr. So you'll probably notice that some of those do not exist anymore and that TikTok is not there. So remember, this was done in 2014 and we were working with students in 2018. So this is the graph that the students saw. So on the left, they were looking at which social media were used the most. You take a look at that graph, you see that Facebook is by and large the most frequently used social media. Well, when we told the students this, or when they found it themselves by looking at the graph, they said, there's something wrong with this data. This is not true. We know based on our experience that people don't use Facebook this much. So we scurried back and looked at the source of the data set and suddenly realized to our chagrin that the data were 4 years old. So this is where we realized, okay, context. You really have to be sure that you remember when the data were collected and from whom. So we were kind of abashed and came back to the students and said, you're right. these data are 4 years old. But they said to us, well, you know, if the data are 4 years old, then probably that means that the students who are older are more likely to use Facebook, because we know it was more common back then. So they said, let's look at the age of the students compared with what social media they use the most. And they made the graph on the right here. And they saw that, in fact, what they had predicted was true, that if you look at the 17-year-olds, which are at the top of the graph, they are much more likely to use Facebook than the younger students. So their hypothesis, after our embarrassment, that older students would be more likely to use Facebook, and was borne out by the data. So this was a wonderful example of students, teenagers, taking control and being empowered by data. Since for us, data and the ability to work with data is really an issue of power. So after this, the students said, let's collect our own data. Let's see what is true about the people that we are here in this class with. And they collected data from their own group, added it to the data set, and then created final projects in which they looked at questions that they were interested in themselves. And here's an example of one of them. So here's the final presentation that one girl did. And she included both the data from the Pew Center and the data that she had collected from her peers. And you can see in her graph here that there are many more data points that the Pew Center had provided than the bottom line, which are the points that the data that she had collected. The question that she decided to look at was, how do you talk to your closest friend online? And she had a bunch of really interesting observations about the graph that she created. And I'm going to read some of them to you. So she said, I noticed that a very few amount of the interviewees refused the question or chose the something else option. This probably means that the other options, game site, phone call, social media, and text, are the most common online communication methods for people who have the internet or a phone. So she's thinking about the people who the data were collected from and the fact that there weren't a lot of others or doesn't apply to me. Probably her most interesting observation is there were no female interviewees that used video games as their primary communication method. So she can see that because in the graph, the purple are females and the orange are males. And she can see that there are no purples who were using video games. So she's saying there are no female interviewees that use video games as their primary communication method. While it is simply a stereotype that video games are more for boys than girls, I think people tend to follow these stereotypes subconsciously, nervous about stepping out from the crowd or standing out. But then she says, however, this is simply a theory, not meant to offend anybody. It's a very socially conscious young woman. She did make note of the fact that there were many more points in the Pew interviewees. And she said the Pew interviewees outnumber the Malden ones 191 to 12. So we can't really assume a lot about Malden. And Malden is the town where we were doing this and where she had collected her data. And then finally, her overall message is texting is the most popular way of communicating. I assume just because of how easy it is and how quickly and simply the receiver will get the message. And so she's looking at that far right bar, which is much bigger than any of the rest. And social media is the second most popular way of communicating, which I assume is because of how big and trendy social media has become, especially Instagram, Snapchat, Twitter, and Tumblr. Most people own these apps and social medias, and the ones that are addicted or use it constantly would definitely use social media as their primary communication method. So all in all, I think this is a pretty impressive ability to take data that were given to her, to collect some of her own, and to make some conclusions that she has been careful to be clear that she's not sure about, especially the small number of people in Malden. And but to make some connections between the data and the world as she knows it, and teenagers as she knows them. So I think it's a great example of her having power over data and using those 5 central data concepts of context, variability, aggregate, visualization, and inference. Thank you, and I'm happy to answer any questions.